Yeah, good afternoon, children. Good afternoon, Anintika, Lakshana, and Gayatri. Lakshana and Gayatri. Good afternoon, children. Yeah, I don't know if the others are joining, so let's begin. We'll first discuss the answers to the assignment which I shared on exponents, and then we'll continue with linear equations in one variable. And that's the chapter we started off, I think, in the last session. So we'll continue with that. We'll discuss the answers to this assignment first. Yes, one by one, tell me. Anantika, what's the answer for the first one? Read from your book. Okay, before that, have you all completed this assignment, children? Anantika,
Yes, ma'am.
What about Anantika?
Yes, ma'am. 1 second.
Yeah, please keep your assignment with you. Open. Yes, then I'll get started with Gayatri. Gayatri, the first answer.
Yes, ma'am. 8.46 into 10 power 2 into 10 power 7, ma'am.
Oh, you must simplify that. 8.46 into 10 power 2 into 10 power 7. Then you need to simplify this. What is 10 power 2 into 10 power 7? 10 to the power 9. Yeah, right. Correct. You're right, Gayatri.
Thank you, ma'am.
Yeah, children, the answer, see, in the portal, when you log into the portal, you can see three things. You can see exams, library questions, and library answers. So in the, the course library answers, I'll be sharing this PDF there. So you don't have to take a screenshot in case you're wrong. In case you've gone wrong with the working, you don't take the trouble of taking screenshots and all that. Once we discuss the answers, this PDF will be uploaded there. So you can see the answers. It will always be there. Okay, you can even use the library to, like practice. You can use the library to practice. I put the questions and answers separately because, you can work it. You can see the questions work and then check your answers. That's why I have maintained two different things: library questions and library answers. So this assignment, the assignment questions will be in library questions and the answers will be in library answers. So there are three courses available there for you. The three courses are exams, CBSE-VIII exams, then CBSE-VIII library questions, library answers. You will find assignments and questions and answers. In questions, you will find assignment questions. Answers, you will find assignment answers, which will always be there. Yeah, so just check your answers. Now, if you're wrong, use a pencil and cross it. If you're right, you can just put a tick against the answer. If you're wrong, make a note of it, just cross it so that you can, go to the library and look for the correct answer later, and you can practice that. Yeah, next one, Lakshana. I don't want the steps. I want only the final answer. What's the final answer?
Ma'am, it's 0 point followed by 7 zeros and 3.
0.7 zeros and 3. 0.2, 3, 4, 5, 6, 7 zeros and 3. Very good, Lakshana. Next, Anantika. Yeah, good afternoon, Shreya. We just started discussing the answers to the assignment on exponents. Yes, Shreya. Anantika, answer for this one.
The answer is 2 by 3.
2 by 3. Yeah, you're right. 2 by 3. 2 by 3 is the answer. So I have given you two different ways of, arriving at the answer. One is using the rule. The first one is using the rule a by b to the power m. You can see that both the, terms are raised to the same power minus 1. Both of them are raised to the same power minus 1, and it's multiplication. So this goes with the rule a by b to the power m into c by d to the power m. The powers are the same, m. Bases are different, a by b, c by d. Bases are different, A by B, C by D, but the powers are the same, M. So what is the rule? This is equal to multiply the bases, A by B into C by D, the whole power M. Multiply the bases and raise it to the same power M. So you can see multiply the bases 3 by 5 into 5 by 2 and raise it to the same power minus 1. So then cancels 3 by 2 to the power minus 1, which is 2 by 3. Or you can also do it like this, without using the rule, without using this rule, this rule. So 2 by 3 is the correct answer. Yes, Shreya, the answer for this one? Quick, we can't spend a long time discussing the answers. Answer for this one, Shreya? Shreya is not there. Harsha? Good afternoon, Harsha. Okay, so back to Gayatri. What's the answer for this one?
Yes, ma'am, this is 8 by 3 to the power x plus 2, ma'am.
8 by 3 to the power x plus 2. That is the... No, what's the answer? Next, Lakshana.
Ma'am, x value is 6, ma'am.
6. Anantika, do you have the same answer?
Yes, ma'am.
Yeah, x is 6. Again, I've given you two different solutions. Two different approaches, I mean, not two different solutions, two different approaches to answer this question. Two, or I think, okay, only two I've given you. So here I have, in the first one, you can see that I've changed the base to 8 by 3 everywhere. If it was 8 by 3, I retain it as 8 by 3. Where it is 3 by 8, I change it to 8 by 3 in the first approach. In the second approach, I have the base as 3 by 8 everywhere. In the first approach, the common base is 8 by 3. In the second approach, the common base is 3 by 8. If it is already 8 by 3, then change 3 by 8 to 8 by 3. In the second approach, if it is 3 by 8, retain it like that. If it's 8 by 3, make it 3 by 8. So in short, in the first approach, everywhere the base is 8 by 3. In the second approach, everywhere the base is 3 by 8. Accordingly, you need to make the changes. Okay, x is 6. Very important questions, children. Everything we do in the classroom here, everything is important. Nothing is less or more important. Everything is equally important. Because you never know, which question you're going to get in the paper. So give equal importance for, every question and answer, be it MCQ or long answer type questions. It all adds to your knowledge. And if you're a math enthusiast, willing to take up math after 10th standard, then you need to take extra efforts to remember everything you learn here. Yes, children. So this is about answer to the question number 4, exercise 6. Yeah, next one. Lakshana. I'm sorry, I have another student, Laksha, in 9th standard. So I get confused. I don't know. I should. Okay, Lakshana in class 8. I'll see that I don't make that mistake. Lakshana, the value of x to the power minus 1 here.
Ma'am, 25 to the power minus 1 or 1 by 25.
X to the power minus 1 is 1 by 25. Very good. Very good. Very good, Lakshana. Lakshana, I had shared all the videos on exponents. Is it with you?
Yes, ma'am.
Okay. And you watched them?
Yes, ma'am. I watched it.
Okay. Very nice. I'm happy to know that, you were able to get the answer to this one. Very nice. Okay. Others?
Yes, ma'am, same answer.
Okay.
Same answer, ma'am.
Very good, Shreya. So you just have to be very careful, now, yeah. See, you need to first plan the process. You need to plan the process. So what is your plan? What is your plan to achieve the answer? So see what I've done here. So first, this negative power, I make it positive. So reciprocal of the base and negative of the power. So 4 by 5 becomes 5 by 4 and minus 2 becomes plus 2. Then I'm changing. See, always when you have this division sign, no, make it multiplication. That's what we normally do. That's what we normally do. See, when you have x is equal to 4 by 5 divided by, something like 8 by 10. Next step, what we do, we change this to multiplication and write this as 10 by 8. Do the same everywhere. Wherever you encounter a division symbol, change it to multiplication in the next step. So see, division becomes multiplication. When division becomes multiplication, what do? We write the reciprocal of the next term or the expression. Write the reciprocal of this one. And while writing the reciprocal, I don't want the positive power to become negative. So I want 2 to remain 2. So I take the reciprocal of the base, 1 by 4, 4 by 1. So it's something which is planned. Here, I don't want the negative power. I don't want minus 2. So I have to write the equivalent of this one. I have to write the equivalent of this one. So 4 by 5 becomes 5 by 4 and minus 2 becomes plus 2. I'm happy with this. Division becomes multiplication. Okay, then we have to write the reciprocal of this one. Reciprocal can be done in 2 ways. So here, we wouldn't like to lose 2. That is a positive 2 as the power. So write that as it is. Then change the base. 1 by 4 becomes 4 by 1. Now you can see that the bases are different, but the powers are the same. Bases are different, but the powers are the same, 2, 2. So it's like this one, a by b into, you can use this rule. A by b to the power m into c by d to the power m is equal to multiply the bases a by b into c by d, the whole power m. So multiply the bases 5 by 4 into 4 by 1, which is nothing but 4, the whole square. So 4 gets cancelled. 5 square is 25. Now we got the value of x, but the question is to find the value of x to the power minus 1. So if x is 25, x to the power minus 1 will be 25 to the power minus 1. First find the value of x. Then x to the power minus 1 is 25 to the power minus 1 or 1 by 25. So I think here, I've just demonstrated that you can also do it without using the rule. So 5 by 4 whole square is 5 by 4 into 5 by 4. And 4 by 1 whole square is 4 into 4. So 4 gets cancelled and 5 5s are 25. Yes, Shreya, what's the value of this expression? Anantika?
Yes, ma'am. So the answer I got is 27 upon 512.
Okay. Gayatri? Answer. Harsha? Okay. 19 by 64 is the correct answer. 19 by 64 is the correct answer. Okay. So children, look out for the, the connecting sign. It's minus. So you cannot use it. Disable your mic, children. The connecting sign is minus. So you cannot use any law here. See, when bases are here, the bases are different, but the powers are the same. You cannot use the rule because the connecting sign is minus. When the connecting sign is minus or plus, you cannot use any law of exponents. Most of the laws of exponents are when the bases are connected by a multiplication or a division sign. So this one, children, don't get confused. This one is not 1 by 3 minus 1 by 2, the whole power minus 3. It is not that. We cannot create our own rules. It's not 1 by 3 minus 1 by 2, the whole power minus 3. You cannot say that the bases are different, but the powers are the same. So I subtract the bases and raise it to the same power minus 3. No, that it doesn't work.
Ma'am, I'm sorry. That's what I actually did, ma'am.
Oh, that's what. Shreya, is it? No problem.
Yes.
Yeah, we learn by making mistakes. It's nice you made that mistake. You will not do this in the exam. So if the connecting sign was a multiplication sign, yes. Or if it was division also, you can do it. If it was division also, you can write divide the bases and raise it to the same power minus 3. So that rule applies only for multiplication and division, not for addition, subtraction. See, a by b to the power m plus c by d to the power m is not equal to a by b plus c by d the whole power m. Plus or minus, I'll see whether it is plus or minus, it's not equal. Whether it is plus or minus, it's not equal to a by b plus or minus c by d the whole power m. It's not equal to. But a by b the whole power m, whether it is multiplication or division, into c by d the whole power m is definitely equal to a by b. Put the connecting sign, whether it's multiplication or division, whatever, it works for both. C by d the whole power m. So when the bases are different, and the connecting sign is multiplication or division. See, there are three things. Bases are different. Connecting sign, multiplication or division. Powers are the same. Then you can use the rule. Bases are different. In fact, even if bases are same, you can use this rule. Even if the base, okay, see, you can use this rule even like this. See, like, supposing you have 2 by 5, the whole power, say like 10 into 2 by 5, the whole power, say like 25. Now here you can use any rule. Like bases are same and it's multiplication, add the powers. Add the powers. Add the powers. You can do that, or you can also do this. Multiply the bases. Okay, sorry, here the power should be the same. Sorry, the power should be 10 here also. So the powers are the same, the bases are also the same. It's okay, you can still use the rule. So 2 by 5 into 2 by 5, raise it to the same power 10. Raise it to the same power 10. You can also work this as 2 by 5, the whole power 10 plus 10. In both the cases, you will get the same answer. Let me write this again. I'm saying bases are same, 2 by 5, 2 by 5. Bases are same. The powers are also the same. Then you can deal with this situation in two different ways, meaning you using two different laws of exponents. Either ways, you'll get the same answer. So when you say the bases are same and it's multiplication, you can add the powers. So 2 by 5, bases are same. So 2 by 5 and it's multiplication. So we add the powers. So the answer is 2 by 5 to the power 20. Or you can use the rule a by b to the power m. Powers are the same. So what do? You multiply the bases and raise it to the same power, right? Same power 10. Multiply the bases and raise it to the same power 10. So now this is nothing but what is 2 by 5 into 2 by 5? I'm just trying to say that the answer is the same in both the cases. So what is 2 by 5 into 2 by 5? 2 by 5 the whole square. 2 by 5 into 2 by 5 is 2 by 5 the whole square. So see here 2 by 5 the whole square, the whole power 10. So when you have many powers, multiply the powers. If you have a raised to the power m, whole power n, whole power p. Multiply the powers. So it is a to the power m n p. Multiply the powers. M into n into p. M n p. There can be only one base, but you can have that base can have multiple powers. Only one base, but it can have multiple powers. So how do you deal with multiple powers? Multiply all the powers. M into n into p into whatever, how many ever powers are there. So here also 2 by 5 into 2 by 5 is 2 by 5 the whole square. A into a is a square. 2 by 5 into 2 by 5 is 2 by 5 the whole square. There's already a power 10, so into 10. There's already this power 10. So what is that? 2 by 5 to the power 20. So it's the same. It is the same. See, even if you write this as 4 by 5 to the power 10, when you like find the value of this and the value of this, they'll be the same. It will be the same. They may look different. 4 by 5 to the power 10. 2 by 5 to the power 20 looks different, but their value, when you calculate the value, that's going to be the same. So children, here negative power, so we cannot simplify. See, now when the connecting sign is plus or minus, you will have to actually you'll have to convert the question to the fourth standard, addition, subtraction of fractions. If the power is, see, when the connecting sign is plus minus, okay, we don't have many laws of exponents supporting such situations. Most of the laws of exponents support multiplication and division, not addition, subtraction. So then what do we do in such situations? If the power is negative, you cannot simplify that. So make the power positive. That's the first step. Make the power positive. So once you make the power positive, your question will somewhat look like, subtraction or addition of fractions or numbers. Adding, subtracting numbers, it will become. So that's all you can do. So when the power is minus 3, you have to simplify using the usual method of taking LCM or something like that. So the power is negative. So this cannot be handled. So you have to make it positive. So 1 by 3 becomes 3 and the power is positive 3. 1 by 2 becomes 2 and positive 3. So it's like you're actually finding the value. What is 3 cubed 27? What is third? See, don't create your own rules. Again, 3 minus 2 the whole power 3. Is there a rule like that? Don't simply write 3 minus 2 the whole power 3. No, you must have a rule. If you're writing this, what is the rule? Is there a rule like that? A to the power m minus b to the power m is equal to a minus b the whole power m. Is there a rule like that? No. Yeah. So 3 cubed is 27. 2 cubed is 8. 27 minus 8 is 19. And here we have divided by 4 cubed. Okay, this is 4 cubed, which is 64. 19 by 64. Now, children, we understand that assuming that all of you here have not got the answer correct, okay? Assuming so. Ask yourself if what you see on the screen is clear. And then if you feel what you have worked is also correct, you can share that with me now. Or if you realize your mistake, yeah, I shouldn't have done this, then that's good. If you still feel that what you've done is right, you can probably share a picture of that on WhatsApp with me.
No, ma'am, I've understood.
Yeah, okay. So remember that we don't have laws of exponents supporting addition, subtraction as the connecting signs. Most of the laws are based on multiplication and division as the connecting signs. So when you have plus minus, you have to do the actual simplification. Like what you see here. Here there is no rule used. We have not used any law here. The regular calculation, 3 cubed, 3 into 3 into 3, 27. 2 cubed, 2 into 2 into 2, 8. Yeah. All right, children. Next one. Yeah. Harsha is not able to stay in the meeting consistently. I think she has some issues. She's been leaving and joining. All right, Shreya. What about the answer for this one, Shreya? Anybody can? Okay, Anantika?
Yes,
Ma'am,
ma'am.
can you
I think, ma'am, the answer
Yes,
for
Shreya.
question.
Okay,
Yes,
Anantika.
ma'am. I think the
yeah.
answer is 250.
250. Okay, Shreya. Yes, Shreya.
Ma'am, I'm facing some internet issues because I'm attending this class in my grandmom's phone as my mom's busy. That's why I can't stay in the meeting for almost like 10 minutes or 11 minutes. That's why.
I'm so sorry about that.
I stay, ma'am. Stay.
Okay, darling. Fine, fine, fine. Okay. I'll share the meeting once we finish the class. I'll download the meeting recording and share it with you. Watch it, okay? Yeah.
I'm not leaving right now, ma'am. I'll stay, ma'am, but I'm
Yeah,
not
please,
sure.
please. Yeah, you can hold. Yeah, you stay, you stay. Yeah. Yes, children. So Anantika said 250. Shreya, what's your answer for this?
The same one, ma'am.
250. Gayatri?
Yeah, ma'am, same, ma'am.
Same. Lakshana? And Harsha?
Ma'am,
Same? Yeah, even I'm getting the same answer. 250. 250. So see, these steps are just to make it student friendly. These steps, So see here, I've first written this is in the numerator. This is also in the numerator. See, actually, from this step, you can write this straight away. You don't have to show these two steps actually. These two steps are not needed. From this, you can directly write this. I'll tell you how. If the power is negative and you want to make it positive, simply change the position. I told you there are two positions, numerator and denominator. There are two positions, numerator and denominator. So if the power is negative and that term is in the denominator, change the position, bring that term to the numerator. This sign will change. If it's plus, it will become minus. If it's minus, it will become plus. Both ways. That's all. So see here, 8 to the power minus 1. No, I'm not happy with a negative one. I want a positive one. So simply change the position. Bring that down to the denominator. It becomes 8 to the power plus 1 or 8 to the power 1 or simply 8. I'm happy with 5 cubed because the power is positive. So I retain it in the numerator. I retain that 5 cubed in the numerator. Now in the denominator, we have 2 to the power minus 4. Again, not happy. Okay. We need to have a positive 4. So change the position, bring that to the numerator. So you can see here, this 8 to the power minus 1 goes down as 8 and 2 to the power minus 4 comes up to the numerator as 2 to the power plus 4. Just observe these two, children. Observe these two. This was 8 to the power minus 1 in the numerator. So it's come down to the denominator as 8 to the power 1, which is 8. Then this 2 to the power 4 was in the denominator as 2 to the power minus 4. So we lifted it to the numerator. So once it comes up to the numerator, minus 4 becomes plus 4. So from here you can write. This one you can write straight away. Now this 5 cubed, it's fine. You don't want to do any changes with that. So leave it in the have it in the numerator itself, wherever it is. Okay, so these two steps actually are extra. If you can understand this, fine. Otherwise, so I've written this one and then this one, and then this one is in the denominator. If this is in the denominator, how do you write it? See, like if you have x by y, how do you write it? X into 1 by y. X by y is nothing but x into 1 by y. 5 by 4 can be written as 5 into 1 by 4. Similarly, this denominator 2 to the power minus 4 should be written as into 1 by 2 to the power minus 4. How do you write a term which is in the denominator? If it's in the numerator, you can write them like this. Denominator into 1 by 2 to the power minus 4.
Yes, ma'am.
Very good. Then this one is 1 by 8. You understand? This one as it is. And please use the rules, and it's like this. Now I've multiplied all the numbers, these three. So 5 cubed into 2 to the power 4 divided by 8. I'm not saying these two steps are not needed. You can write it like this. You can also write it straight away like this. Yeah, then it's the usual calculation. 5 cubed, and I think you can follow all this, children. Okay. Yeah, what's the value of this one?
Ma'am, Anantika?
Yeah,
Ma'am, 2.
2.
Yes,
Others
ma'am.
can share. Yeah, others.
Ma'am, I got it like 60 upon 23.
Lakshana 60 by 23. Okay.
2 to the power minus 1.
Meaning 1 by 2. 2 to the power minus 1 meaning 1 by 2. Correct?
Yes, ma'am.
See, the connecting signs are plus minus. So you don't have any rule here. You have to actually find the values, and then here you will get fractions, LCM. That's what you have to do here. Okay,
Yeah,
so
I
can I
also
have the
got
answers?
2, ma'am.
Yeah, can I have the answers again? Anantika, you said
Ma'am, 2.
2, then
Ma'am, Shreya 2, ma'am.
2, then
Ma'am,
2 to the
Lakshana 60 by 23.
Lakshana, please come again. 2.
60 by 23.
Oh, 260 by 23, like this, huh?
No, ma'am, only 60 by 23.
Oh, okay, 60 by 23. Gayatri, you said 2 to the power minus 1 or 1 by 2. Anyone else? Okay, Harsha, you mentioned that you have some internet issues, so I'm not disturbing you. Wow, 60 by 23. I think that was Lakshana.
Yes, ma'am.
Very good, very good.
Thank you, ma'am.
Yes, I'll just stay in the slide for some time. I told you when there's plus minus, there is no rule. So you have to make the negative power positive like this. Make all the negative powers positive. And you should start simplifying from the innermost thing. You cannot use this power minus 1 first. Which one is dominating? You should always come from the innermost stuff. You cannot do anything with minus 1 in the first step itself. You must start from the innermost terms, these. So this one is 1 by 3, 1 by 4, 1 by 5. Then I told you, now you have fractions. So this is like fourth standard, third, fourth standard, LCM and all that. So you get 23 by 60. Now the power is minus 1. Now use this power. Very good,
Yes,
Lakshana.
ma'am, I multiplied the powers. That's why I got it wrong.
Okay, so you multiply like this, son. This into this, is it?
Yes, ma'am.
Ma'am,
Yeah.
I have a doubt in this slide.
Yeah, please ask me. Yes, Shreya.
From where did we get 20, 15, and 12? Like, is it due to the LCM, ma'am?
Okay. Now, yeah, I'll work it for you. Yeah, it's due to the LCM, correct. What's the common denominator? 60. Okay. So 3 into 20 is 60. So that into 20 in the numerator. 4 into 15 is 60. So into 15. 5 into 12 is 60. So into 12. So 1 into 20 is 20. 1 into 15 is 15. And 1 into 12 is 12. So yeah.
Okay, ma'am.
Yeah. Is this all, children, or did I give you any other assignment?
Ma'am, also
Ma'am,
second
homework 2.
one.
Second one also. Okay. Yeah, final answer, please.
Ma'am, I didn't get with the base 4, but with the base 2, I got 2 raised to the power 12.
2 power
Yes,
12,
ma'am.
is
2
it?
raised to the power
Yeah,
4
ma'am.
and 4 raised to the power 6, ma'am.
Correct. 4 raised to the power 6. Anantika, see, from this Anantika, now the base is 2, right? You want 4 as the base. So you know that 2 square is 4, right?
Yes, ma'am. Ma'am, I got it now.
Into 6. So write 12 as 2 into 6.
Yeah, ma'am. I got it now.
Okay.
Ma'am, I don't get this question at all, ma'am.
No problem. I'll tell you now. See here. So we need to, like express 4096 as a product of its prime factors. So we need to express the given number 4096 as a product of its prime factors. So we are all aware of this procedure. Do that. And you can see here, we have expressed 4096 as a product of its primes. And it has only 2 as a prime factor. 2 happens so many times. 4096 has only 2 as a prime factor. There is no other factor, prime factor. So 2 happening 12 times. So 4096. And we've also understood that repeated multiplication is written in the exponential form. Repeated addition is multiplication. Repeated addition is multiplication. Repeated addition is multiplication, 4 into 2. Repeated addition is multiplication. Repeated multiplication is written in the exponential form. So here we have repeated multiplication. So exponential form. 2 multiplied with itself 12 times. So 2 raised to the power 12. So that is 4096. So 4096 in base 2. In base 2 can be expressed as 2 to the power 12. In base 4, you can see here 2 2's make a 4. 2 2's make a 4. So how many 4's? 2, 3, 4, 5, 6 4's. So it's 4 into 4 into 4, 6 times. So 4 to the power 6.
Actually, I wrote it, but I didn't see, and then I told that I didn't get it.
Okay. No, I can make it more clear if anyone still doesn't understand.
Understood.
See, what does the question mean? Express 4096 in the base 2 and base 4. Base 2 and base 4. So this is how, so 4096 in base 2 is 2 to the power 12, 2 raised to the power 12. And 4096 in base 4 is 4 raised to the power 6. Yeah. Yes, quickly. Answer?
Ma'am, -1, Anantika.
-1. Yes, others?
Ma'am, 1.
1.
Ma'am, I just can't do it, ma'am.
Okay, fine.
I'm just a bit confused of this.
Okay. Okay, so
Ma'am, I
see.
got 6, ma'am. Shreya, ma'am, I got -6.
Okay, fine. See, -1 raised to the power -5. See, before we do this, we should know the reciprocals of 1 and -1. That's very important. What is the reciprocal of 1? What is the reciprocal of -1? So going down to, I think, 6th standard, we have learned that 1 and -1 are their own reciprocals.
Yes, ma'am.
1 and -1 are their own reciprocals. The reciprocal of 1 is 1. The reciprocal of -1 is also -1. Let's see that. But you all know the reciprocal of 1 is 1 only. What is the reciprocal of -1? Reciprocal of -1. -1 means -1 by 1. See, -1 means -1 by 1. What's the reciprocal? -1 by 1. It's the same thing. Remember that 1 and -1 are their own reciprocals. So, -1 to the power -5 is equal to reciprocal of the base, negative of the power. So what's the value of this one? -1 multiplied with itself 5 times is -1 only. I'm doing it separately for you. I'm like working only for this one. Then you know what to do. I'm working only for this one. How do you handle -1 to the power -5? Reciprocal of the base, -1. Negative of the power, 5. Now, what is -1 to the power 5? -1 multiplied with itself 5 times. So 5 times you'll get the minus sign. So it will be minus only. And 1 into 1 into 1 into 1 into 1 is 1. When you multiply the minus sign 5 times, you get minus. And 1 multiplied with itself 5 times is 1.
Ma'am, we can
one.
also see that if the power is odd or even. If it's even, then it will become positive.
Yeah. So -1 raised to an odd power is negative. -1 raised to an even power is positive. Yes. So now the next one is this. Reciprocal of the base. Negative of the power.
So 1.
Yeah. This one is already fine. This is -1. Now multiply all this. So it's a positive one. This is nothing but this. This is nothing but this. This is nothing but this. Wherever the powers are negative, make it positive by taking the reciprocal of the base. And while doing this, you should remember that 1 and -1 are their own reciprocals. The reciprocal of 1 is 1. The reciprocal of -1 is also -1, is -1 itself. So -1 to the power 5 means what? -1 multiplied with itself 5 times. So 1 into 1 into 1, how many ever times you'll get 1 only? The signs, minus sign 5 times. So it's negative because the power is odd. Now, what is 1 raised to the power 5? Is it -1 or +1? Odd power.
-1, ma'am.
Yeah, all of you share your thoughts. -1 or +1?
Ma'am, +1, ma'am.
+1. Okay.
Yes, ma'am.
But the power is odd, no?
Yes, ma'am. But
it has no -1.
see, it is not -1. It is +1. And when it's raised to an, let's say, odd number, which is it's not even -5 or like that, so it will still remain positive, because if you multiply 1 5 times, it will be still positive. But if it's -1 into 5 times, then it will be negative.
Correct. So when 1 is raised to 1 raised to even odd, whatever power is 1 only, because it's 1. It's 1 multiplied with itself. Whether 1 is multiplied with itself even number of times or odd number of times, the result is 1. 1 multiplied with itself 3 times, 5 times, 99 times, whatever, even number of times, odd number of times. Answer is 1 only. You'll have to be careful only when -1 is raised to an even or odd power. -1 raised to an even power is +1. -1 raised to an odd power is -1. Only when it is negative, -1 odd power -1. But -1 even power +1. when 1 is raised to an even or odd power, it's always 1. It's 1 only, no? Then from where will we get the minus sign? Right.
Yes, ma'am, understood.
Very good. Yeah, exponential form. Yeah, answer? Anybody? Answer? Lakshana?
Ma'am,
Ma'am,
can I say?
power
7 to the power?
4.
Okay, 7 to the power 4. Anintika?
Ma'am, 2.401 into 10 raised to the power 3.
Can you just read your steps if it's possible?
Ma'am, I put it in its standard form.
No. Exponential form is different from standard. Exponential form must have two things, base and power. Exponential form is, now when you have a base raised to some power, this is the exponential form. Exponential form. Base, power, this is the exponential form.
Yes, ma'am.
So you need to find the prime factors. 2401, 7, 343 times, 749 times, 7 sevens are, 7 ones are. So 2401 in the exponential form is 7 raised to the power 4.
Ma'am, I thought it will be, I thought it would be, a part of the divisibility rule of number 2. So I accidentally multiplied it with 2, so I didn't even get the answer.
How can you multiply by 2, Shreya? You divide it by 2.
I was confused with the last one, ma'am, so I was just totally out, ma'am. That's why.
No problem, yeah. Exponential form meaning base power. This is the exponential form of, if you have to write 2401 in the standard form, then Anintika, you're right. It's 2.401 into 10 to the power 3. Standard form is different. Exponential form is different. Now the question can also be express 2401 in base 7. In base 7. So 7 to the power 4. See, it's not my choice to divide by 7. You can, all this answer is unique. You cannot get a different answer. You cannot choose to divide by some other number. You cannot divide by 2, 3. It's not, this number is not divisible by 2, 3, 5. So all of you will get 7 only. It's not that what if I divide by 3, what if I divide by 5? It's not divisible. This prime factorization is unique. See, you might get the numbers in different order. Supposing the factorization of a number has 2 2s, 1 3, and like 1 5 and 1 7. You might get it in a different order. See, you might have first divided by 7 and then by 5. Then you'd have used the 2s and then 3. The order might be different, but the prime factors will be the same for all of us. That is unique. Compare.
Ma'am, Anantika?
Yeah.
Ma'am, so 5 raised to the power 3 is smaller than 3 raised to the power 5.
Okay. This
Ma'am,
one,
can I see the second
Ma'am,
one?
which is greater?
Can I see the second one?
Yes, Shreya.
Ma'am, it's 2 to the power 100, ma'am.
Okay, that's greater, right?
Greater.
yes, ma'am.
Yeah. Here. Third one. Lakshana, Gayatri, Harsha.
Ma'am, it's 3.4 into 10 to the power 15.
That's greater, is it?
Yes, ma'am. Ma'am,
Okay.
as for the A option, I got 5 to the power 3 greater than 3 to the power 5.
No, 5 cubed is 125, right? 5 into 5 into 5. But 3 to the power 5 is 243.
Oh, okay, ma'am.
3 power 5 is 3 into 3 is 9. 9 threes are 27. 27 into 3 is 81. 81 into 3 is 243.
Sorry, ma'am. I wrote the question wrong.
You wrote 3 cube, is it?
Yes, ma'am. I wrote it like 3 cube.
Okay.
Okay, ma'am.
Anybody wants the working for the last one? I can work it for you, the last one, because I haven't shown the steps.
I have, a tip, ma'am. When
Sure.
I was seventh standard, my teacher actually taught me something. It might not always be right, but sometimes it may be right. I have to see if the I have to see which power is greater, and with that power, I can find out that's greater, no matter what the number is.
Okay, go on. Yeah. For C, is it?
No, ma'am, for almost everything.
Oh,
My teacher told you can use it, but sometimes it may not work, so you better check it out. So I checked it out, and it was right, ma'am. So that's what I did.
okay. Just a minute, children. I'm getting a call. Just a minute. Yes, children. Thank you. So here what you have to do is 4.5 into 10 to the power 14. But this one is 3.4 into 10 to the power 15. So it's difficult to compare. Difficult meaning you cannot compare in the face of the expressions. See, now we always have some criteria for comparing. Like for example, okay, let me write this first. For example, which one is greater? Which is greater, A or B? Which is greater?
Ma'am, A.
A is greater.
B.
B is greater.
Sorry, B is greater. I didn't count the digits correctly.
Yeah,
B
see
is
that?
greater.
That's the criteria. So that is the criteria. So what was the criteria? Counting the digits first. Then we have the next thing. So the criteria, there's an order. So the first thing you will do is to count the number of digits. So when you count the number of digits, B has more number of digits when compared to A. So clearly or straight away, B is greater than A. In the same way, you need to compare with some criteria in your mind. Just like that, you cannot say that this is greater or that is greater. So what is the criteria here? So here it will be bring, you see, we have 10, right? Bring it to the same power in both. So 4.5 into 10 to the power 14. Let this be as it is. 3.4 into 10 to the power 15 can be written as 10 to the power 1 into 10 to the power 14. Now we have come a long way down in exponents, so you should understand this. I can only wait for you to understand. I'm not explaining why. We can write 10 to the power 15 as 10 to the power 1 into 10 to the power 14. For obvious reasons. I'm not saying why. Now 3.4 into 10 is what? 34. 3.4 into 10 is 34 into 10 to the power 14. Now it's convenient to compare. Why? Because 10 to the power 14, 10 to the power 14. So now you can just compare these numbers. So 34 is bigger than 4.4. So this one is greater. Is that okay, children?
Okay. I got it, ma'am.
Yeah.
Yes, ma'am, got it.
Yeah. So what you can do here is you can bring 10 to the power 15. You can change this to 10 to the power 1 into 10 to the power 14. And you must have only 10 to the power 4. See, there should be only two parts. The first part like this into 10 to the power 14. So here the first part is 34 into 10 to the power 14. So it's like you don't check this at all. Both in both the expressions we have into 10 to the power 14. So you can ignore this. So the first part 4.5 34. 34 is bigger. So that means this one is bigger. So if you want the steps, the second one should be written as 3.4 into 10 to the power 1 into 10 to the power 14. Now, 3.4 into 10 is 34 into 10 to the power 14. So now the second parts are the same. 10 to the power 14, 10 to the power 14. You can ignore that. Now compare the first parts. That's it. Yeah. Product of primes. All right. You can understand. If you have not got this answer, later I told you the PDF will be posted in library answers. You can go there and check. Yeah, this also is simple, children. Check.
Yes, ma'am. Same answer.
Got it, ma'am. It's all correct, ma'am.
Same answer, ma'am.
Ma'am, once again, put it the previous answer.
Yeah.
Ma'am, you have expanded and simplified it, right, ma'am?
Gayatri,
Ma'am,
now what's your question?
you have expanded this and simplified it, ma'am.
Not needed. You can just, it depends on the marks. So like if it's for 2 marks, you have to show the steps like this. Otherwise, you can write the answer straight away. You can write this answer straight away, Gayatri.
Okay, ma'am.
You can write it straight away. You can also present it like this. You can also present it like -4 the whole cubed into m the whole cubed into n squared the whole cubed. You can also present it like this.
Okay, ma'am.
This is nothing but the power 3 is for every, every part of this -4 mn square. So the cube applies to -4, the cube applies to m and n square. So you can also show it like this.
Okay, ma'am.
So you can write it as -4 the whole cubed into m the whole cubed into n square the whole cube. So this is -64 m cubed. And when you have many powers, multiply the powers. So 2 3s are 6. Yeah.
Okay, ma'am. Now I got it.
Yeah, you can go with this one. All of you can go with this one. This is like very elaborate, just so that all of us understand. Is it fine?
Yeah, ma'am.
Yes.
Okay.
Yes, ma'am.
Okay.
Ma'am, I'm not getting this question right, ma'am.
1/16 only, ma'am.
Oh, sorry, ma'am. I actually did a mistake here, ma'am.
Correct?
Yeah, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, this I have to tell you. So here, children, you need to break down the numbers or you need to write the numbers as a product of their prime factors. So 12 should be written as 2 into 2 into 3. Because 12, 2 6 are 2 3s are 3 1s are. So 12 is 2 into 2 into 3. So like this, you must break down every composite number and write it as a product of primes. You can break down every composite number and write it as a product of its primes. Primes meaning prime numbers. So 12 is 2 into 2 into 3, whole power 4. 9 is 3 into 3, that is 3 squared. 3 into 3 or 3 squared, the whole power 3. And 4 is 2 squared. 6 is 3 into 2, then this power 3. Then 8 is 2 cubed. Or you can write 2 into 2 into 2, and then in the next step 2 cubed, and that power 2. And 27 is 3 cubed. Now, what have we done here? So like this, we have written all the numbers with base 2 or 3. With base 2 or 3. So now in the next step, 2 to the power 4 into 2 to the power 4 into 3 to the power 4. You can see here. And here multiply the powers. 2 3s are 6. 3 to the power 6. 2 squared. Denominator 3 cubed. 2 cubed. The power is applicable to every term in the bracket. So 3 cubed, 2 cubed. This one multiply the powers. 2 3s are 6. 3 cubed. Now in the numerator we have 2, 2 and 2. So add the powers. 3, 3, add the powers. Denominator 2, 2, add the powers because multiplication. Here also add the powers. Then on adding you get this. And then again division it is. Now base are same, it's division. So subtract the powers. You can see here. Base are same, it's division, subtract the powers. Subtract the powers. That's it. I told you the fundamental, the criteria like with which you get started. So you need to break down the numbers. If you see a composite number, break it down and write it as a product of its primes.
Okay, ma'am. Understood.
Yeah, that's how you get started. You need to get started. You need to get started correctly. That will lead you to, the correct steps further. So your start is very important. So I have written the LHS and RHS both in base 10. The left hand side is 10 to the power 11. The right hand side should also be written as 10 to the power something. Only then you can compare. See, I told you, what is the criteria for comparing here? The base should be the same. See, the criteria is different in different situations. For comparing, you cannot have the same criteria for any situation. So when we had to compare numbers, we first count the number of digits. Then this one, what was the criteria here? So it's different in different situations. So here what we did, we tried to have the second part the same, the second part 10 to the power 14 in both, so that we can compare the first one alone. Here both are different. The first part is different, second part is also different. So how do how do you conclude? How do you judge it? So have something fixed so that you can compare only the other thing, the two other things. That's the criteria. In the same way here, the criteria is we'll have both as 10 to the power something. So this one is 10 to the power 11. So this also we'll write in base 10. So first 100 is 10 square. 100 is 10 square. Then this power 11. Now 2 into 11. Now 2 into 11, 22. Multiply the powers, 2 into 11, 22. So now we have both the expressions in base 10. We have this one and this one in base 10. This one is 10 raised to the power 11. This one is 10 raised to the power 22. Now it's easy to compare.
Ma'am, but I'm having a doubt, ma'am.
Yes.
Ma'am, if we put 10 power 0 means that's 1, right, ma'am? So 1 into 10 power. Oh, okay, ma'am. Sorry, ma'am. I thought that's 10 power 11, ma'am.
So you're saying this 10 is 10 power 0, is it?
Yes, ma'am.
10 is 10 power 1. 10 power 0. 10 raised to the power 0 is 1.
Yes, ma'am.
Simply 10 means 10 to the power 1.
Okay, ma'am.
So children, see, it's been 1 hour 15 minutes since we started the class, and we're still discussing the answers. So this session will, I believe all of you, from the way you're discussing and sharing the answers with me, it looks like as if all of you have completed your work. But please remember, only if you complete the assignments, this discussion will make sense to you. Otherwise, it will be boring and it's almost like wasting your time. So please complete assignments given so that the class is interesting and there is scope for you to discuss, share your answers and discuss. And you can get the best out of the session. Yeah, this one, please check it yourself. If you have any questions, you can ask me.
Yes, ma'am. 1 second. Ma'am,
Yeah.
For the B, I got 700 into 10 raised to the power 6.
700 is more than 10. The first part.
Yes, ma'am. Got it.
All right, ma'am.
Yeah.
Yes, ma'am, I took out all right, ma'am.
Very good. So see, it's like to write a number in the exponential, sorry, in the standard form or the scientific notation, the first part, okay, can be 1 or anything more than 1, but less than 10 into 10 raised to, say, power n, where n is an integer, where n is an integer. Usual form. So this one, usual form is, children, using the place values. Using the place value, you should not multiply and add. It's not multiplication session. You should not do that. See, the place values 10 power 6, 10 power 3. So in the, see, 10 to the power 6, 10 to the power 5, 10 to the power 4, 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. This is the ones place. 10 power 0 is 1. Ones, tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs, and so on. So 10 to the power 6, we have 7. Then we don't have anything here. Then 5 here. Then fill. All these places you must fill. So you must, these questions you must write in the usual form using the place value chart. Using the place value chart. Using the exponential place value chart. So 10 to the power 5, we have 6. 10 to the power 4, 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. Understood, children?
Understood, ma'am.
Yes, ma'am.
So similarly, the last one, in the place value 10 to the power 7, we have the digit 9. 10 to the power 6, 0. 10 to the power 5, 0. 10 to the power 4, 0. 10 to the power 3, 0. 10 to the power 2, we have 4. 10 to the power 1, we have 3. Then 10 to the power 0. You don't have anything here, so 0. This is the expanded form of a number, expanded form. Okay, so this is 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5. So 1 into 10 to the power 5 plus 2 into 10 to the power 4 plus 0 into 10 to the power 3 plus 7 into 10 squared plus 1 into 10 to the power 1 plus 9 into 10 to the power 0. Power 0, 1, 2, 3, 4, 5, and so on.
Okay, ma'am.
So standard form, exponential form, expanded form. Read it carefully. If you have to, now the exponential form is different. Writing this number in the exponential form is different. This is the expanded form. You can also write this number in the scientific notation or the standard form. So please read the question carefully since you know many things. You should not assume like, oh, maybe it's this. Read carefully and answer the question correctly. How many more? Oh. Yeah. See, you have to rewrite the statement expressing the number involved in the scientific notation. You'll have to rewrite the statement. So what is the statement? The statement is speed of light in vacuum is 300 million meters per second. You must write the statement again, rewrite the statement. But the number involved should be in the scientific notation. So what is given to us? Speed of light in vacuum is 3 million. So you should first write that number. How do you write 3 million like this? This is 3 million. Ones, tens, hundreds, 1,000, 10,000, 10,000, 100,000, 100,000, million. This is million. So 300 million. So 300 million meaning 300 should be followed by so many zeros.
Yes, ma'am.
International system, children. Yes. International system. Let me write again. Ones, tens, hundreds. This is a bundle. 1,000, 10,000. 1 second, children. Yeah. 1,000, 10,000, 100,000, 100,000. International system. Ones, tens, hundreds, 1,000, 10,000, 100,000, million, 10 million, 100 million. So 300 millions. So under 100 million, you must write 3. 300 million. So 100 million, how much? 3. So under 100 millions, you must write the digit 3. Under every place value, you can write only 1 digit. Under every place value, you can write only 1 digit. You cannot write 2 digits under 1 place value. So this one is 300 million. So under 100 million, we have the digit 3. So the rest of it is 0. The rest of it is 0. And now this number should be written in the in the scientific notation, which is this.
Ma'am, can I ask a question?
Yeah.
What comes after billion, ma'am?
Trillion.
Trillion.
Tri. Trillion.
Okay, ma'am.
Ma'am, after trillion?
No, I don't know. I don't know. After billion is trillion, 10 trillion, 100 trillion. Beyond that, I don't know. There must be something. I have not expanded my knowledge beyond that. Yeah.
Mama searched online and saying quadrillion.
Oh, okay. Yeah. Q meaning for 4. Yeah. See, knowledge is everywhere. It's abundant, you know. So you have to be an earnest learner. And I am one, but you know, my chores keep me engaged, right? So I don't have space to improvise on my knowledge. That's what it is. Otherwise, I love to read and keep learning new things, but it's a monotonous life, right? So I'm just stuck to my work, and there's absolutely no scope of reading and learning anything new. Yeah. Yes, children. Yeah. So here we use a rule. Bases are different, but the powers are the same. Bases are different, but the powers are the same. And it's multiplication. It's not addition, subtraction. It's multiplication. So you can see here, 2 to the power 6 into 3 to the power 6 into 5 to the power 6. Bases are different, but the powers are the same, and it's multiplication. So multiply the bases and raise it to the same power. Now 6 5 are 30, 30 to the power 6. 3 to the power 6 is 729, followed by 6 zeros. 30 to the power 6 is 30 into 30 into 30 into 30, 6 times. 30 multiplied with itself 6 times. Yeah, so 3 multiplied with itself 6 times is 729, so followed by 6 zeros. Yes, children. Done?
Yeah, ma'am.
Yeah. Now,
ma'am.
yeah, I prepared all the children. Yes, children. So I prepared 2 more assignments. Have I shown it in the library questions or no?
Yes, ma'am, it's there.
Yes, ma'am. It's on it, ma'am. Yes.
It's visible also, is it? Is it visible?
Yes, ma'am. It
Yes,
is visible.
Okay.
Like,
Yeah. So now
Yeah.
that we have discussed the answers to 1 and 2, 3 and 4, we will not discuss the answers. I think if the questions are visible today or by tomorrow, I'll try to upload the answers also. I'm sure the answers are not visible. Have I posted the answers also? No, right?
no, ma'am, you haven't posted
No.
answers for exponents at all.
Ah, very good. Yeah, that's what I wanted. Yeah. So now I'll show up all the answers in the library answers by tomorrow. Once I update something in the portal, I'll let you know. So you don't have to keep checking, So you will get all the updates on WhatsApp. So you just stick to WhatsApp and follow the messages there. So once I, update the portal, I'll let you know. So by tomorrow, I'll try to upload all the answers. Answers to homework 1, 2, 3, and 4. So 3 and 4 you completed and you have to check the answers yourself. If you have any doubts, then you can ask me in the class. We'll not see the answers one by one like this.
Ma'am, about the test.
Yeah, no, tell me what was it? Yeah, I have to reschedule that, right? Yeah. So how many of you finished? Let me see.
Ma'am, I finished. Shreya finished.
Okay.
Ma'am.
Yeah.
Ma'am, in the test, just get the correct answers, ma'am, but the answers are changing, ma'am. When I give it, confirm the answers are changing, ma'am. Yes, ma'am.
Ma'am, the first one, linear equation.
Yeah. Correct. All right, yeah. Gayatri, the answers kept changing, meaning when you go to the next one, the answer you selected earlier changes, is it?
Yes, ma'am.
Did the same thing happen to anyone else here?
No, ma'am.
No, ma'am.
Because that's quite unlikely, answers changing, but okay, Gayatri, oh, that's why you've got 9 incorrect, is it, Gayatri?
Yeah, ma'am.
Oh. Okay, fine. Okay, so children, I'm going to, reschedule the same exam. Those who have already finished it, you need not take it up again. I'm going to reschedule. I'm going to end this exam. I'm going to end this exam and reschedule the same exam. Okay, for some reason, I'm going to reschedule the same exam. So now Lakshana, you have completed, Harsha has completed, Shreya, Ariston. Now, Gayatri, you said you had some difficulty while doing the exam, so you can redo this. Okay?
Okay.
And Anantik also, you had some trouble while doing the exam, so you can redo. So the same exam I'm going to reschedule for Gayatri and Anantika. The others need not redo the exam. You will see the same exam again, but don't do it. Just ignore it. Okay?
Ma'am.
Yeah. And for Gayatri and Anantika, the exam will be available till tomorrow, 9 o'clock. Then I'll end it.
Okay.
So you have to finish it by tomorrow.
Okay, ma'am.
Yes,
Yeah.
ma'am, I'll finish it today itself.
Okay, fine.
Yes.
Children, I'll just share another link. Join the meeting using that link, okay? Leave this meeting. Please rejoin using the new link which I'll be sharing now. All right?
Okay, ma'am.
Okay,
Yeah.
ma'am.
Yeah. Thank you, children.